This question is from GATE 2012, Mechanical Engineering paper, question number 1. In abrasive jet machining, as the distance between the nozzle tip and the work surface increases, the material removal rate, option A, increases continuously, option B, decreases continuously, option C, decreases, becomes stable and then increases, or option D, increases, becomes stable and then decreases. Let's see how the material removal rate changes with the change in distance between nozzle tip and work surface. Now in abrasive jet machining, which is nothing but AJM, the removal of material due to which cutting happens is due to the impingement by fine abrasive particles. So material removal happens because of the impact created by these fine abrasive particles, and they are being shot out of a nozzle in the airstream with high impact. This causes a brittle fracture on the material that is to be cut. Now the graph between nozzle tip distance is nothing but distance between the surface of the workpiece and the nozzle, while MRR, which is nothing but material removal rate, can be shown like this. So from the trend we can see that initially with the increase in nozzle tip distance, the material removal rate is increasing, not linearly but non-linearly. At a certain point it becomes maximum, then it almost remains stable, and then it decreases. So we can see that first increases, then remains stable and then decreases is our answer. Why this happens? Because when the fine abrasive particles leave the nozzle, they will accelerate, and therefore initially when the nozzle tip distance increases, their velocity also increases, and because of the increase in velocity they create a higher impact, because of which the material removal rate increase. While further, when the nozzle tip distance is increased beyond a particular value, that is this value, we see that the atmospheric drag on the particles becomes significant. So as the nozzle tip distance from the surface increases, the atmospheric drag has a significant value now because of the higher distance, and therefore the velocity will eventually decrease for the abrasive particles, and due to which the material removal rate also decreases. So these are the reasons why initially material removal rate increases when the nozzle goes away from the surface. It remains almost stable for a further increase in the distance, while from a particular value, if the nozzle tip distance is increased, we see that because of the atmospheric drag being significant now, the fine abrasive particles will become slower and material removal rate will decrease. Let's go back and mark the correct option. We can see that the option that we discussed is option D, that is the material removal rate increases as the distance between the nozzle tip and work surface increases, while it becomes stable and then decreases. To learn about abrasive jet machining in detail, you can refer to the NPTEL video lecture 14, abrasive jet machining, that is AJM. This is from the course Introduction to Abrasive Machining and Finishing Processes. This course is by Dr. Mamilla Ravishankar. He is from Department of Mechanical Engineering, IIT Guwahati. I hope this explanation will help you clear your doubt. Thank you.